Okay, so this is the fourth or the last part of generative AI in computer vision. Technologies contributing to disadvantages in computer vision. There are several technologies that contribute to the disadvantages of computer vision. One example is transfer learning, which involves reusing or reusing pre-trained models of new tasks. While this can be an efficient way to develop computer vision applications, it can also result in biases or inaccurate results if the pre-trained models were trained on biased or unrepresentative data. Another technology that can contribute to disadvantages in computer vision is deep learning, which involves training several or a neural network on large data sets of labeled data. While deep learning has revolutionized computer vision, it also requires significant amounts of labeled data and can be computationally inexpensive. Mitigating and disadvantages of computer vision. To mitigate the disadvantages of computer vision, several strategies can be employed. One strategy is to use diverse and representative data sets for training computer vision models. To reduce the potential for bias and discrimination, another strategy is to use algorithms techniques that are robust to variations in input data, such as convolution neural network. These algorithms can help to reduce the potential or unrealistic or distorted output in computer vision applications. Overall, while computer vision has significant potential in the realm of generative AI, it is important to carefully consider its disadvantages and to develop strategies to mitigate these issues. By doing so, we can ensure that computer vision is used responsibly and ethically, and that it provides accurate and beneficial results for a wide range of applications. Variational autoencoders, VAEs. The VAEs are a type of generative AI model that can be used to generate new data points, such as images or music. VAEs are a type of neural network that can learn to represent complex data in a low-dimensional space, known as a latent space. This latent space can then be used to generate new data points that are similar to the original data. In the context of generative AI, VAEs are used to generate new data points that are similar to the original data but are not identical. For example, a VAE could be trained on a data set of images of flowers and then be used to generate new images of flowers that are similar to the original data set but are not exact copies. VAEs work by encoding the input data into low-dimensional latent space and then decoding this latent representation back into the original data space. This encoder and decoder are trained together using a loss function that encourages the encoded representation to be meaningful and decoded output to be similar to the original input. One of the advantages of VAEs in generative AI is that they can generate a wide range of new data points rather than simply copying or slightly modifying existing data points. This makes them useful for tasks such as image and music generation, where there is a high degree of variability in the data. Another advantage of VAEs is that they can be used to generate data that is more diverse and novel than traditional generative models. By sampling from the latent space of a VAE, it's possible to generate new data points that are not present in the original data set, but are still possible based on the learned distribution of the data. Applications of VAEs. VAEs have many applications across the wide range of industries such as large compression. VAEs can be used for image compression by encoding images into lower dimensional representation and then decoding the representation back into the original range. Speech processing. VAEs can be used for tasks such as speech recognition, speech synthesis, and voice conversion. Recommendations system. VAEs can be used to generate personalized recommendation for users based on their past behavior and preferences. Drug discovery. VAEs can be used to generate new drug candidates by encoding the chemical structure of existing drugs into a low-dimensional representation and then decoding the representation to create new drug candidates. Benefits and risks of VAEs. VAEs have several benefits, including their ability to compress and construct data with high accuracy. VAEs can also be used for a wide range of applications, from image compression to drug discovery. Additionally, VAEs are more interpretable than other generative models, which can be beneficial in applications where understanding the underlying data is important. However, VAEs also pose several risks, including the potential for overfitting and the difficulty of evaluating the quality of the generated data. VAEs can also be vulnerable to bias and errors if the training data is biased or flawed. In short, VAEs are a powerful tool for generative AI, allowing for the creation of new data points that are similar to the original data, but not identical. By encoding data into a low-dimensional latent space, VAEs can generate a wide range of new data points that are diverse and novel. Real-world example of generative AI. As we see, generative AI has numerous applications in the real world, from creative industries to industrial and medical applications. Now let us explore some examples of how generative AI is being used today, as well as advantages and disadvantages of these applications. Creative applications of generative AI. Generative AI has significant potential for use in creative industries such as art, music, and fashion. By leveraging machine learning algorithms, artists and designers can create new and unique content that would be difficult or impossible to create manually. For example, in the field of art, generative AI has been used to create new forms for digital art, such as deep dream images, which use convolution neural network to generate abstract and surreal images. In music, generative AI can be used to create new compositions or even generate entirely new musical styles. In fashion, generative AI can be used to design new clothing styles or generate digital models that can be used in virtual try-on applications. By using generative AI to create new content, artists and designers can push the boundaries of creativity and create content that is truly unique. Industrial applications of generative AI. Generative AI also has numerous applications in industrial settings, particularly in manufacturing and product design. By using generative AI to design products, engineers can create more efficient and cost-effective designs, while also reducing the time and resources required for product development. For example, generative AI can be used to optimize the design of aircraft or components, resulting in lighter and more fuel-efficient designs. In automotive manufacturing, generative AI can be used to design components such as engine parts or suspension systems, resulting in more efficient and reliable vehicles. Medical applications for generative AI. Generative AI also has significant potential for use in the medical field, particularly in the areas of drug discovery and medical imaging. By using generative AI to analyze medical data, researchers and doctors can gain new insights into disease and develop more effective treatments. For example, generative AI can be used to design new drugs by analyzing the chemical properties of existing drugs and generating new chemical structures that may be more effective. In medical imaging, generative AI can be used to analyze images such as X-rays or MRI scans, helping doctors to identify potential health issues more quickly and accurately. Financial services. Generative AI has numerous applications in the financial services industry, particularly in the areas of risk management and fraud detection. By using generative AI to analyze financial data, banks and other financial institutions can gain new insights into customer behavior and identify potential risk and fraudulent activities. Hedge funds can be leveraged the processing power of generative AI to quickly analyze large financial data sets and extract key insights. This allows them to benchmark against comparable and make faster data-driven decisions. With the help of intelligent applications, hedge funds can generate incisive reports in a matter of minutes, reducing the need of traditional financial analysts who rely on manual data processing. Ultimately, this could be mark the end of the models and bottles financial analyst era, as generative AI solutions enable faster and more accurate decision making. Chatbots and voice bots. Generative AI can also be used to develop chatbots and voice bots, which are computer programs designed to simulate conversation with human users. Chatbots and voice bots can be used in wide range of applications, including customer service, marketing, and personal assistants. Chatbots can be used in e-commerce to provide customers with information about products, help them make purchasing decisions, and provide support after the purchase has been made. Voice bots, on the other hand, can be used to provide hands-free assistance in environments such as cars or homes. Generative AI disrupts the status quo. Generative AI has the potential to transform numerous industries by enabling faster, more accurate, and cost-effective decision making. However, as with any technological disruption, it also has the potential to threaten traditional industries and job roles. One area where generative AI could have a significant impact is in the field of SEO copywriting. By using natural language processing techniques, generative AI can be used to create unique, high-quality content at scale, reducing the need for human copywriters. This could have significant implications for the copywriting industry, which has traditionally relied on human writers to create content for websites, blogs, and other online platforms. Another area where generative AI could have an impact is in the back office management. By automating tasks such as data entry and processing, generative AI can reduce the need for human workers in these roles. This could result in a significant cost savings for businesses and organizations, but could also lead to job losses in the back office management sector. Generative AI could also have an impact on the legal industry, particularly areas such as contract drafting and tax advice. By using machine learning algorithms to analyze legal documents and tax codes, generative AI could be used to create customized legal documents and tax advice at scale, reducing the need for human lawyers and accountants. This could have significant implications for the legal and accounting industries, which have traditionally relied on human expertise to provide these services. However, it's important to note that while generative AI has the potential to transform these industries, it's unlikely to completely replace human workers. Instead, generative AI is likely to augment human capabilities and allow workers to focus on higher level tasks that require human judgment and creativity. Additionally, the accuracy and effectiveness of generative AI output will depend on the quality of the data used to train the models, as well as the domain-specific context provided. Risks associated with not adopting generative AI. While generative AI has many benefits, there are also risks associated with not adopting this technology. Some of the risks include falling behind the competition. Businesses that do not adopt generative AI risk falling behind their competitors, may be using this technology to create new products and content more efficiently. Inefficiency. Businesses that do not adopt generative AI risk being less efficient than their competitors, who may be able to generate new designs and products faster and with less cost. Missed opportunities. Businesses that do not adopt generative AI risk missing out of opportunities to create new products and content that could be highly profitable. Conclusion. Generative AI is a powerful subfield of machine learning that has the potential to revolutionize the way businesses operate. By enabling computers to generate new data that is similar to what a human might produce, generative AI can be used to create new designs, products, and content. There are several types of generative AIs, including GANs, VAEs, and auto-regression models, each suited for different applications. However, there are also risks associated with not adopting generative AI, including falling behind the competition, inefficiency, and missed opportunities. By considering these factors, businesses can make informed decisions about whether to adopt generative AI in their operations. Thank you.